Good day, viewers. Today we want to solve some questions on dimension. Okay, let's see. A question says the period t of a pendulum bob depends on the mass m, the length l, and the acceleration due to gravity g. Derive the equation for the period t. So let's say, okay, solution. We have t is equals to, it depends on, so since it depends on, so we don't know the constant value, so we're going to write m raised power x, l raised power y, g raised power z. The next thing we are going to do is to find the dimension of period. The dimension for period is t. We have, this is a question on dimension. The period t of a pendulum bob depends on the mass m, the length l, and the acceleration due to gravity g. Derive the equation for period t. So what we're going to do is to write this equation. Since period t depends on, k is standing for the constant. We don't know what the constant of proportionality is. It was not given in the question. So we have m, the mass raised to power x, the length raised to power y, and g raised to power z. The next thing is to write the dimension of each of these values. For period t is still t, because period is the time, so it is time. So then mass, we write it as capital letter M, and then the length is capital letter L. Then the g is the dimension for acceleration due to gravity is lt raised to minus 2. Excuse me. So the next thing is to put in all these values. So we have t equals to k mx ly, then lt raised to minus 2z. Then this, we can open it up. We have k ms ly l raised to power z times t raised to power minus 2z. Then combining them, we have ms ly plus z dot t minus 2z. Now this t equals to, so we can write this, since there is no value of m and l here, so we can write it as m raised to power 0, l raised to power 0, then t raised to power 1. Then we do comparing of coefficients, or comparing the indices. So comparing the indices. For m, at the left hand side we have 0, at the right hand side we have equals to x. For l, at the left hand side we have 0, at the right hand side we have y plus z. From here we can say x equals to 0, and this we can imply that y equals to minus z. Then for t, we have 1 equals to minus 2z. Divide both sides by minus 2. Then we have z equals to minus 1 over 2. Then putting this into this equation, so we can say y equals to minus z, which is minus half, which is equals to half. So therefore, we have x equals to 0, y equals to half, and z equals to minus half. Then we can now put all those values back into the equation, the first equation. we have t equals to k m raised to power 0 l raised to power half g raised to power minus half. According to indices, g raised to power minus half is same thing as writing km as 0 l raised to power half times 1 over g raised to power half. Then I can combine them together and say t equals to k m raised to power 0 is 1. I'll do that. Okay, so g raised to power half. This one becomes 1. So we have k l raised to power l over g. I can combine them together and write it as half using indices laws. Then from here, note that nota bene that a raised to power half is the same thing as square root of a. So t equals to k square root of l over g. So this is the relationship between the time and the length and the acceleration due to gravity, the period of a simple pendulum. That means that the mass is not a factor in the period of a pendulum bulb. So from the equation we can see that the mass became 0, so it became 1. Yeah, so it does not have anything to do with, it does not affect the period of a simple pendulum. So questions like this may be asked in an exam. So get the, is either you are asked to find the values of the y, x, y, and z, or you are told to find the expression. So the real equation for the period of a pendulum bulb is 2 pi L over G. So this is one of the use of dimension. This is use of one of the use of dimension, and one of the use is to get the equation relating the equation or the formula of a particular quantity. Another use is to check. Okay, so this is WAEC SSC 2020 question 4. The velocity v of a wave in a stretched string, depends on the tension T in the spring and the mass per unit length mu of the spring. Obtain an expression for V in terms of T and mu using the method of dimension. Okay, so what we have to do, we need to write V is equals to, that means it depends on a constant value T and mu. So let's use A and B for this as the indices for the two quantities that we're having. Okay, now let's find the K is dimensionless. That means there is no dimension, is a constant, is dimensionless. So the velocity V, the dimension for velocity V is V. Dimension for tension. Tension is a type of force. Under types of force, we have contact force and non-contact force. So tension is a type of contact force. So we have tension T equals to, so it's a force, and the dimension for force is m l t raised to minus 2. That's mass by acceleration due to gravity. So if you remember this, force equals to me. M is lt raised to minus 2. So that's what we got here. Now, then we also have mass per unit length. Mass per unit length. That's mu. Mu is mass per unit length, from the word mass per unit length. So that is these are the dimensions for each of these parameters. Then we put it into the equation. Let's say equation 1. So put everything into equation 1. We have v, velocity is lt raised to minus 1. So we're going to put that into lt raised to minus 1 equals to K. So we leave out K for now. It's dimensionless. So we have tension is M L T raised power minus 2 raised power A. Then for mu, that is mass per unit length, we have M L raised power minus 1 raised power B. So we open up the bracket. The bracket we have M raised power A times L raised power A times T raised power minus 2A times M raised power B times L raised power minus B. Then we take collect like terms. We have M raised power A plus B because we have M times A. Then we also have L raised power A minus B times T raised power minus 2A. And this is equal to T minus LT raised power minus 1. So we don't have the M value here, so we can take it as M raised power 0 because anything raised power 0 is still 1. So M raised power 0, L raised power 1, T raised power minus 1 equals to M raised power A plus B times L raised power A minus B times T raised power minus 2A. Then we comparing the indices. So for M, at the left hand side we have 0. At the right hand side we have A plus B, equation 1. We have for the L we have 1 at the left hand side. At the right hand side we have A minus B, equation 2. Then we have T. At the left hand side we have minus 1, and at the right hand side we have minus 2A, equation 3. From here we can say from equation 3 we can say divide both sides by minus 2. So when we have divide both sides by minus 2, minus 2, so A equals to half. And from equation 1, we already know that A equals to minus B. If this one crosses to the other side, A equals to minus B. B equals to minus A. So it implies here that B is also equal to minus A. Therefore, we can say our B equals to minus half. So these are the values of A and B that we have here. So we can put it into the equation. We have V equals to K, T raised power half, then mu raised power minus half. From the law of indices, this becomes K T raised power half over mu raised power half. And from indices law, which says that when you have A raised power half is the same thing as square root of A. So we can write that V equals to K square root of T over mu. Therefore, quite easily done. So we have been able to derive the equation for the velocity of a wave in a stretched string, which depends on the tension and the mass per unit length of the spring. So this is this is just a way of solving using dimension analysis to solve and derive the velocity or the velocity of this particular wave